Wireshark is one of the most widely used network protocol analyzers in the world. It allows you to capture and interactively browse the traffic running on a computer network. In the context of cybersecurity and DevSecOps, Wireshark is an essential tool for understanding what is actually happening at the network level, diagnosing problems, detecting suspicious behavior, and analyzing how protocols work in practice. You have already used tools like Nmap to scan ports and traceroute to observe network paths. Wireshark goes further. It lets you look inside the packets themselves, reading their content layer by layer. Before diving into the interface, it is important to understand what Wireshark actually does. When data travels over a network, it is broken into packets. Each packet contains headers, metadata describing where it comes from, where it is going, which protocol is used, and sometimes a payload, the actual data being transported. Wireshark captures these packets as they pass through your network interface and displays them in a human-readable format. This process is often called packet sniffing or packet capture. Wireshark can capture traffic from many types of network interfaces: wired Ethernet interfaces, wireless Wi-Fi interfaces, loopback interfaces, which handle traffic that stays within your own machine, and virtual interfaces created by tools like Docker or VPN software. Choosing the right interface is the very first step before starting any capture. The Wireshark interface. When you open Wireshark, the first screen you see is the welcome screen. It displays a list of available network interfaces on your machine, each with a small activity graph showing live traffic. For example, you might see an interface named ETH0, a common name for a wired Ethernet interface on Linux, VLAN 0, a wireless interface, or LOW, the loopback interface. On Windows, interfaces are typically named things like local area connection or Wi-Fi. You simply double-click on the interface you want to monitor to start capturing. Once a capture is running or once you have opened a saved capture file, the main Wireshark window is divided into three main panels. The Packet List panel, top panel. This panel shows a list of all captured packets, one per line. Each line displays key information at a glance: the packet number, an internal sequence number assigned by Wireshark, the timestamp, when the packet was captured, relative to the start of the capture by default, the source address, the destination address, the protocol identified by Wireshark, the packet length in bytes, and an informational summary. For example, you might see a line showing packet number 42, captured 3.215 seconds after the start, from source IP address 192.168.1.10 to destination IP address 8.8.8.8, using the DNS protocol, domain name system, with a length of 74 bytes, and a summary saying standard query a google.com. This gives you an immediate overview of all traffic. The Packet Details panel, middle panel. When you click on a packet in the top panel, the middle panel expands a tree structure showing all the layers of that packet, from the lowest level up. For instance, for a typical web request, you would see a frame entry, the raw capture information, then an Ethernet layer, showing source and destination MAC addresses, then an Internet Protocol version 4 layer, showing source and destination IP addresses, time to live, and other fields, then a transmission control protocol layer, showing source and destination ports, sequence numbers, flags like SYN, ACK, or FIN, and finally an hypertext transfer protocol layer, showing the actual HTTP request, such as get/index.html http/1.1. This layered view directly reflects the OC model layers you have already studied. You can expand or collapse each layer by clicking the arrow next to it. The Packet Bytes panel, bottom panel. This panel shows the raw bytes of the selected packet in hexadecimal on the left and as readable ASCII characters on the right. When you click on a field in the Packet Details panel, the corresponding bytes are highlighted in the Packet Bytes panel. This is particularly useful when you want to understand exactly how a protocol encodes its data, or when you are looking for specific values in a packet. Starting and stopping a capture. To start a capture, you either double-click an interface from the welcome screen or click the blue shark fin button in the toolbar. To stop a capture, you click the red square stop button. During a live capture, packets appear in the Packet List panel in real time, which can be very fast on a busy network. It is perfectly normal to see hundreds or thousands of packets appear within seconds. Once you stop a capture, you can save it to a file. The standard file format used by Wireshark is the PCAP format, short for packet capture, or the newer PKPing format, packet capture next generation. These files have the extensions PKP or PKP and can be shared, reopened later, or analyzed by other tools. In cybersecurity work, sharing a PKP APAP file with a colleague or including it as evidence in a vulnerability report is common practice. Using filters. On a real network, you will often capture thousands of packets in a very short time. Without filtering, finding relevant information would be extremely difficult. Wireshark offers two types of filters. Capture filters are applied before the capture starts. They limit which packets are recorded in the first place, which saves memory and storage. Capture filters use a specific syntax called Berkeley packet filter syntax. For example, the capture filter port 80 will only capture packets using port 80, typically unencrypted web traffic. The filter host 192.168.1.5 will only capture packets involving that specific IP address. Display filters are applied after packets have already been captured. They do not remove packets, they simply hide the ones that do not match, allowing you to focus on what interests you. Display filters use Wireshark's own powerful filter language. Some essential examples. HTTP shows only packets using the Hypertext Transfer Protocol. TCP.port = 443 shows only packets using port 443, typically encrypted web traffic. IP.address = 10.0.0.1 shows all packets where either the source or destination IP address is 10.0.0.1. TCP.flags.sin = 1 and TCP.flags.ac = 0 shows only the first packet of a transmission control protocol handshake, the initial SYN packet, which you studied when practicing with Netcat. DNS shows only domain name system traffic. http.request.method = GET shows only HTTP GET requests. Display filters can be typed directly into the filter bar at the top of the packet list panel. When a filter is valid, the bar turns green. When it is invalid or contains a syntax error, it turns red. You can also build filters by right-clicking on any field in the packet details panel and selecting Apply as Filter or Prepare as Filter, which is very helpful when you are not sure of the exact syntax. Following a stream. One extremely useful feature of Wireshark is the ability to follow a complete conversation between two endpoints. Right-clicking on a packet and selecting Follow greater than TCP stream or UDP stream or HTTP stream reassembles all the packets belonging to that conversation and displays them in order in a single window, with data sent in one direction shown in one color, typically red, and data sent in the other direction in another color, typically blue. For example, if you capture an unencrypted HTTP exchange, following the TCP stream will show you the full HTTP request, including headers like host, user agent, and cookie, and the full HTTP response, including the response headers and body. This is invaluable for understanding application-level behavior. Practical workflow for a security analyst. In a real security context, a typical Wireshark workflow looks like this. First, you identify the network interface relevant to your investigation and start a capture. If you already know what you are looking for example, only web traffic, you can set a capture filter right away to reduce noise. Second, you reproduce the event or action you want to analyze. For example, if you want to observe a login form submission, you open a browser, navigate to the target page, and submit the form while the capture is running. Third, you stop the capture and save the file for later reference. Fourth, you apply display filters to isolate the relevant packets. For example, http.request.method = post to find form submission packets. Fifth, you click on interesting packets and explore the packet details panel layer by layer to understand what was sent. If the traffic is unencrypted, you can often see usernames, passwords, session tokens, or other sensitive data directly in the packet content. This is precisely why unencrypted protocols like HTTP, as opposed to HTTPS, FTP, or Telnet are considered insecure. Sixth, you use the follow stream feature to read full conversations in context. Finally, you document your findings, potentially exporting specific packets or saving the capture file as evidence. Important notes on privileges and legality. Running Wireshark typically requires elevated privileges, administrator or root access, because capturing raw packets at the network interface level is a sensitive operation. On Linux systems, you can either run Wireshark as root or configure specific permissions to allow your user account to capture packets without full root access. More importantly, capturing network traffic on a network you do not own or do not have explicit permission to analyze is illegal in most jurisdictions. In a professional or educational context, always ensure you are working on an authorized network or a dedicated lab environment. During a penetration test, packet capture is only legitimate within the explicitly authorized scope. Summary of key concepts. Wireshark captures raw packets from a chosen network interface and displays them in three panels: the packet list, overview of all packets, the packet details, layered breakdown matching the OSI model, and the packet bytes, Raw hexadecimal and ASCII content. Capture filters reduce what is recorded. Display filters control what is shown after capture. The follow stream feature reconstructs full conversations. Saved captures use the PK format. Wireshark is a foundational tool for any security analyst, enabling direct observation of protocol behavior, detection of unencrypted sensitive data, and analysis of network anomalies.